Hello, 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 my fellow mathletes. Root Beer here, looking at question number 4 on the 2007 Euclid. Thank you guys for joining me. So let's just jump into it. 4a, determine all values of x for which 2 plus square root of x minus 2 is equal to x minus 2. Alright, so we could just do some algebra and manipulate this, but it sort of just caught my eye. You know, if we call this y, this is square root y. Or I guess maybe if I call this y, then this is y squared. So I have 2 plus y is equal to y squared. That's a quick quadratic we might need to solve. I feel like the answer is probably something like this is 4 and this is somehow 2, and then 2 plus 2 is 4. I can't think of many other numbers that differ from their square root by 2. I'm sure it's possible. Maybe... Ooh, 1 and negative 1. And I'd expect only 2 answers here because of the quadratic stuff. Anyway, let's, stop thinking about it and start writing stuff down. Let's, guess and check is all well and good. And if you just wrote 2 and negative 1 and figured out the x values from there, that's fine. But I'd prefer to write up my solution a little bit. So let's start with the formula we've got. Now the square root sign is a bit pesky, so I'm going to want to square to get rid of it. But I don't want to square with this 2 over here, because if I square it like this, then I'm going to get 4. I'm going to get rid of the square root sign there, because squaring and square rooting will give us x minus 2. But then I'm going to have 4 root x minus 2, and so I haven't really gotten rid of my square root sign. And this is, something that can help you with more algebra manipulations in more complicated questions. Just get the square root by itself on one side of the equation. So we're just going to bring the 2 over to the other side with an x minus 4. Now let's square both sides, and the square root sign completely disappears on the left-hand side. And we get x squared minus 8x plus 16 over here. And now we've got a quadratic. So we'll bring everything over to the right-hand side. X squared minus 9x plus 18. Oh, that looks factorable. Negative 3 and negative 6. If you can't do this in your head, that's okay. That's what the quadratic formula is for. Negative b plus or minus square root of b squared minus 4ac. All over 2a, but when I'm able to, when it's nice numbers like this, I try and factor it in my head to make sure I'm still good at doing that. But you plug negative 9 in for b, and then a is 1, c is 18. You'll get the same answers. So x is 3, or not and. 6. Does this work though? Because you get so that's sort of why I paused while I was writing. I still wrote and or. So yeah, plugging in 3 here, we get 3 minus 2. Square root of 1 though is not negative 1. So while that's certainly a possibility, maybe that's a reason why we don't want to change this to something like this. Because the square root sign here actually means must be positive, or sorry, must be non-negative as an answer. And if I plug in 3, and this is something you should, anytime you get only a few answers, just plug them in really quick to check. 3 minus 2 here. I'll get 2 plus square root of 1 is going to be 1 in this case, because it's what we call the principal square root sign. When it's under this symbol, you can't get negative 1 as your answer. And 2 plus 1 is not equal to 1. However, 2 plus root 6 minus 2 is equal to 6 minus 2, because you get 2 plus root 4, 2 plus 2 is equal to 4. That one's true. So the only answer is x equals 6. X equals 3, we throw out. And you do need to double check these things. So this is kind of, it's something that you should keep in mind. Square root signs like that, the answer must be non-negative if it's going to work. So you got to double check that everything works out there. Another great thing that, or something to keep in mind, not really for question 4, but maybe for like a question 6 or 7, you will sometimes be asked to do things like solve these series of equations that have logarithms in them. Logarithms can't accept negative numbers in them, so that's something else that you want to keep in mind. Logarithms can spit out negative numbers, but they can't take in a negative number. So, you know, if we had something like, I don't know, some stupid equation like this, or, you know, plus with some other function, whatever. You do a whole bunch of work and you get x is 3 or x is -1. Well, the -1 won't work. You can't do log base 10 of -1. Okay, that's just not allowed. So we have to be careful with this because it's sort of an extra layer to the problem. We think we're just doing some algebra, we think we're just solving them. It's a light bulb question, we get our answers, we move on. But, you know, based on the way math is set up, some of the answers just aren't allowed to work. And we have to be aware of that if we want full marks. So if I hadn't been careful there, if I hadn't double-checked and ruled out 3 as a possibility, I probably would have lost a mark. Maybe even more. Alright, so that's 4A there. How about 4B? What have we got here? In the diagram, the parabola intersects the x-axis at -3, 0 and 3, 0. Okay, and it has vertex C right below the x-axis. Interestingly enough, the vertex is going to be right below the midpoint of A and B, so it's going to lie on the y-axis, just as shown. Although, since it's a written question, we'll probably have to remark that. So this guy here is 0 something. Okay. But what else are we told? The area of triangle ABC, so what they have shaded in here for us, is 54. Well, I can tell you the base right here is 6, and the height is going to be this k value, so I think we could probably work out k from there. We're being asked to determine the equation of the parabola, and of course explain how you got your answer. Okay. So, what can we do here? Well, we're going to draw our picture in our notepad, first of all. Okay, and I'm going to say, let C have coordinates HK, but C lies below the midpoint. This is true of all parabolas. It either lies above or below the midpoint of the roots. So since they're -3, 0, and 3, 0, h is equal to 0. So we're just looking at 0k here. Okay, so let's draw in our triangle. And we have to make this comment, otherwise, you know, people will be saying, well, how did you know it lies on how did you know C lies exactly on the y-axis? Yeah, it looks like that on the picture, but the diagrams are not drawn to scale. So we'll put a K, we'll put a 6, and we will make the comment that K is the height of triangle ABC, and 6, which is equal to the distance between A and B, is equal to the base of triangle ABC. So 54 is the area. And that's 1/2 base times height. So that's going to be 3k. So divide 54 by 3 and you will get 18. So k is equal to 18. Okay. What have I actually done here? Am I any closer to actually getting the equation of the parabola? Yeah, I've got some more information, And actually, I have enough information. If I wanted to, I could put this thing in vertex form now. And they don't specify it, right? They don't determine the equation, just determine an equation. Now I've got the vertex, I can specify it in vertex form. So vertex form is y equals a times x minus h squared plus k. Well, I can fill in most of this. So k is, oh, I guess it's negative. So negative k is the height. So negative, negative. So negative k is 18, therefore k is negative 18. Got to be careful about that. So minus 18 here, that makes sense because it's dropping below. Now we would expect a to be positive because it's an upward facing parabola, but can we actually figure out what a is? Absolutely. Because we have some other points on here, negative 3, 0, 3, 0. So we know that if I plug in x is 3, I should get y is equal to 0. So I might say something like, to find a, use one of the points will do, doesn't matter which one. B is 3, 0. So y is equal to a, 3 minus 0 squared minus 18, but that's a times 9 minus 18, and y has to be 0. So it's not that hard to see a is going to be equal to 2. So an equation for the parabola is 2x minus 0, so I guess we can just say 2x squared. Minus 18. Now another way you could do that if you didn't want to do vertex form is we've got the roots of... So by the way, here's my final answer. Question over. I'm just talking about another way to do the question. We've got the roots negative 3 and 3. So another thing we could do is use sort of the root form or x-intercept form and say it's a times x minus 3, x minus negative 3. So this is going to be a times, and multiply these guys out, x squared minus 9, or ax squared minus a times 9. So this is another thing we can do. Just knowing the roots does not tell us a, which is sort of our stretching factor. There's lots of parabolas that we can draw going through negative 3 and 3. So we do need to figure out this a, and that's where knowing one other point, c, would help us. And from there, you know, knowing that if I plug in 0, I get negative 18 out, that'll get me a is 2 as well. So either way, we get this equation, and we've written it up. We've explained what we're doing at each step. And we used vertex form. You could have very easily used root form as well. That's all fine. But definitely needed to figure out the coordinates of C at some point. All right, so that wraps up question number 4. And in the next video, we're going to take a look at question number 5. We'll scroll down and get ready for that. I will see you guys in the next video. Until then, take care.